Greetings, one and all. A beautiful day for a webinar. Thanks for everyone who's dialed in already. I'll give people a chance to come through the virtual turnstiles, but whilst we're waiting for people to just come through, just a reminder, folks, this is the 12th Stormwater Fundamentals series webinar for the year. We've punched out 11 already, and we're now on number the 12th, which is our last for this year. The good news is we're not done yet. We're going to roll out another bunch of hip and learned presenters to present a bunch of other sort of stormwater fundamental topics. So if you're keen to find out more and register when we actually announce the dates and topics and presenters, etc., feel free to jump on our website or subscribe to our newsletter because we'll be announcing it in the newsletter, possibly this month's newsletter if we can get ourselves organised. And just on the topic of the Stormwater Fundamental series, gee whiz, we won an award for it. So the Stormwater Queensland recently had their awards for excellence, and we were lucky enough to pick up the award for excellence in policy and education. So well done to everyone involved. Awesome. Wouldn't be anything without the amazing attendances we get every session. So thanks to everyone who comes along. It's certainly not. It's certainly well appreciated, and we certainly respect your time and efforts, and certainly that of the presenters as well. So we've had some great presenters. A big shout out to the presenters we've had over the year. I think Sean Quilty, Mukhtar, Murray Powell, Daniel Ryder, Dan Rhodes. I'm sure I'm missing some. Harut. So kudos to all those guys, and kudos also to everyone involved in the Worcester Maintenance Compliance Framework. That also won an award for excellence in asset management, and also kudos for the guy who's sort of driving that our own young professional of the year, Daniel Ryder. So Daniel actually picked up the Young Professional of the Award for Stormwater Queensland and Stormwater New South Wales. So well done to Daniel. Multitasking and multi-stating. So good stuff. Hey, and the other big news you might have seen, Ocean Protect, the naming sponsor for the home of the Cronulla Sharks. Can you believe that? So the NRL team, the National Rugby League team in Australia, the Cronulla Sharks, their stadium is now called Ocean Protect Stadium. Can you believe that, Blake? Can you believe it?
Oh,
What
mate,
a
as a Shire local, I'm quite proud, but as a Parramatta fan, a little bit disappointed they didn't choose Combank.
couldn't afford it, I don't think, Blake.
No,
But
probably not.
And a full circle moment, Michael Wicks, our illustrious CEO, I think he might be dialing in today. He started Ocean Protect 23 something years ago in Cronulla. So how about that? 23 years later, have the NRL team name their stadium after the company. That is a hell of a story. And speaking of stories, we've got some great ones at Ocean Protect. We're putting in assets every day uh, uh, of the year. And look, this is some examples. So putting in an ocean save in Hobart to help protect a bunch of turtles in the down. Sorry, turtles, platypus in the downstream waterway. So kudos to Jason Martin. I think Hobart City Council involved in that one. Another one, a jellyfish system going in at Preston. So I think that was a project by Matt Garrow, or led by Matt Garrow. So well on to Matt, and thanks for the photo, Matt. Another further afield in near Adelaide and Littlehampton. You might have heard us talk about this one. This is a Filterra bioretention system. It's about 120 square meters, and this actually treats. This is brand new. This is recently installed. See, the plants are quite immature, but this is actually going to be treating stormwater and recirculated lake water. So there's an adjacent lake you can kind of see in the background. The Filterra is going to treat that lake water, pumped roughly twice a week to keep the lake healthy. So if you're keen to find out more, just reach out. Speaking of Filterras, this is a big one. This is actually the biggest on the planet. And I know Blake had some involvement in this, as did a lot of Ocean Protect legends. And this is the biggest Filterra bioretention system on the planet. Can't actually tell you where exactly it is, but it's in Sydney and it's about 990 square meters. And it would have been a lot bigger if it had been a conventional bioretention. So this is brand new. This is just after installation. You can see some of the plants have got a water as well after installation. So well done to the guys who are involved with that. Particularly that bloke, the big tall guy, Big Ray, who's led the charge on this installation. So well done. Also, just if you're keen to hear some dulcet tones, and our very own Dan Rhodes joins the Ocean Protect podcast this month, talking about doing bioretention better. What a great topic. I think we're still the only podcast on the planet that talks about bioretention systems. And before we dive into the official proceedings of today, just a reminder, folks, if you do have any questions, please put them in the Q&A panel. The slides and recording from today, as per all our webinars, will be also made available on the Ocean Protect website under the webinars tab. And also your CPD forms will be emailed to you within about a week. So, and if you don't receive it, just reach out to marketing@oceanprotect.com.au. But we're going to dive straight into the prezzo, and it gives me a great pleasure to advise that I'm joined by our very own Blake Allingham, who's debuting in the Ocean Protect webinar space. But Blake is no stranger to Ocean Protect. He's been with us for what, 6 years now, Blake? Is it 6 or 7? Maybe
Right, I
more?
don't think this is my debut.
Is it really? When did you come? When did you come further?
About 2 years when we did our second field study trial for PFAS. We did.
Ah, right. Hey, look, a memorable moment, clearly. And apologies in advance. I'm not firing on all cylinders today. I've got food poisoning. So if we have to have a forced intermission at some stage, apologies in advance. But I know Blake will steady the ship if I need to duck elsewhere. And on that, I hope everyone's enjoying their lunch. And for people who don't know Blake, Blake's head of our R&D department. He's been with us many years. Started off as a university student doing part-time work amongst lawn mowing and other things, and climbed the echelons of the Ocean Protect, mega business. No, we're a small bunch of people, but we're pretty cool. But Blake leads all our R&D stuff, including developing, and it has to be one of the best engineering theses of all time, undergraduate engineering thesis, which we'll touch on today, looking at developing the PFAS removal technology, which we're going to touch on briefly today. But we're focusing mostly today on just the problem of PFAS, as in what is PFAS, why is it a concern, what can we do about it? And this for me is a hot topic, and it's a super worthwhile topic to cover as a fundamental series, because the key thing I get asked when I do talks around PFAS is, what is PFAS? It's a massive problem across the planet, but particularly for our stormwater industry. And fundamentally, you don't actually learn or get taught much about it unless you come to something like this. So we're going to cover what PFAS is and the problem of it and what we can do about it. And like I said, it is a massive problem. But first up, what is actually PFAS at all? If you don't know what PFAS is, hey, lucky you. But it stands for per and polyfluoroalkyl substances. And there's about 14,000 or thereabouts different types of PFAS. And that's a key thing. It's not just one or two chemical types. There is loads of different PFAS chemicals. They are manufactured, what we call forever chemicals, i.e. they last in the environment for a very, 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 very long time. They've been produced since the 1930s, but they're used in a whole bunch of products. Subsequently, they are pretty much everywhere now, but there's certainly some hot spots, and certainly they are in stormwater. So it's used in various products, carpets, clothes. You can see there. Particularly firefighting foams is a major source of PFAS in our environment. Pesticides, a lot of pesticides have PFAS in them. And fundamentally, they make products, they have some incredible properties that basically make stuff like your clothes, etc., non-stick, water repellent, etc. And you can see the chemical formula there. But what's all the fuss about? It's a chemical, who cares? Well, there's some pretty significant concerns around PFAS. You can see the characteristics there. It is recognized as being toxic. It bioaccumulates. So as you go further up the food chain, for example, it'll bioaccumulate, sticks to the fatty tissue of us and other animals. And it's fundamentally everywhere. And it's linked to a whole bunch of negative health impacts. So as a result of all those things, it is a massive and growing priority for environmental regulators. Like I said, this is a red hot topic, and it's only going to get bigger. And you might have come across it in various media outlets. So whether you're watching Australian Story or keeping abreast of sort of the massive lawsuits that are happening within Australia and overseas, or you might have just tuned in to see the Incredible Hulk, Mark Ruffalo, star in a movie called Dark Waters, which is based on the book Exposure. Two fantastic little things to come across if you're keen to delve into PFAS and, don't entertain, but in a pretty gruesome way. But there's a whole bunch of articles around PFAS. Fundamentally, it's in our rain. So like even we used to think that rainfall was actually, quite a pure source of water, but fundamentally, PFAS is in rainwater across the planet and it often exceeds safe levels. Um, it's also, unsurprisingly, in our drinking water, and it's also in various surface waters and groundwaters across the planet. That can be a little bit skewed in terms of the concentrations that we're generally looking at, particularly in areas where we know there's PFAS hotspots, but fundamentally it is in surface and groundwaters across the planet at varying concentrations. Obviously, high concentrations where there's known sources of PFAS, but it's pretty much ubiquitous. And if you want some more bad news, it's actually in our beer. So even our beer is not free from PFAS. Obviously, associated with the fact that there's PFAS in surface and waters used for water supply, etc., and that the brewing process doesn't destroy the PFAS. Common misconception is that it's a problem overseas. It's not. It's a massive problem in Australia. Like the highest concentrations of PFAS in dolphins across the planet isn't in Hong Kong or the Philippines. It's in Australia, off the coast of Melbourne and Gippsland. So just off the southeast Victorian coast, the highest concentration of PFAS and dolphins in the world is there. Something like 90% of dolphins washed up have shown to be basically elevated PFAS levels above safe levels, above levels that would be are recognised as causing liver toxicity and other autoimmune diseases in dolphins itself. So this is a massive issue. And obviously, this is coming from the land. Um, we're even finding it in basically very, very remote areas. So one of our recent podcast guests, Dr. Catherine Warwick, from Western Sydney University, looked at PFAS, looked at the platypus. Basically, she picked up 8 platypus carcasses across some very remote parts of New South Wales and found elevated levels of PFAS in all of them. So even in very remote areas within Australia, there is PFAS in our wildlife. It's also on us. So this is a recent publication put out there by the Australian Bureau of Statistics. It's not good news, folks. It basically showed that I think it was PFOS was in 98.6% of all adults sampled. So say that again, PFOS which is a potential carcinogen and linked to a bunch of issues, was in 98.6% of all samples, and 85% of all people sampled had at least 3 types of PFAS chemicals in their bloodstream, and this is just what we can measure. So getting back to that original statement, there's about 14,000 chemicals, 14,000 PFAS chemicals, and we can't monitor or analyze for them all. There's always new ones being developed. So it's very hard to track and test, etc. But yeah, we are seeing PFAS in our blood, and it
The
is
the
fundamental.
the
Sorry, you go, Blake.
the typical suite for analytes when submitting samples for PFAS, it's about
Mm.
20 to 30 of them that we test for. That's a very common suite.
Yeah, yeah. So certainly not 14,000. And as an example, Blake, how much are those tests every time we test for PFAS?
About $300 a sample.
Yeah, not cheap. So it's not a cheap thing to test for, even if you're getting a relatively small number of PFAS analytes being done. So, yeah. But fundamentally, it's not just in our blood, but it's causing problems. So it's basically from top to tail. It's known to cause issues, or at least been linked to potential health issues. Whether it be thyroid disease, breast cancer, liver damage, kidney cancer, testicular cancer, etc. A whole bunch of potential health problems linked to PFAS exposure, unfortunately. We often get asked, is water safe to drink in Australia? This is straight from the what's it, National Health? I can't remember what that acronym stands for now, but fundamentally they suggest that PFAS levels in Australia are generally below current guideline levels. Having said that, we do see instances where we see water supply reservoirs like the Medlow Dam in the Blue Mountains, which you'd think would be pretty pristine. No, that was shut down for a bit when elevated PFAS levels were encountered. And it's not just a problem in Australia, it's a global. And give you an example, this is a map of PFAS contamination across the US. So fairly widespread contamination levels across the US as one example. And the money being thrown at the issue is out of this world. Fundamentally, it'd be a lot easier just to stop using PFAS products and limit our production of them. But obviously, there's a legacy of PFAS contamination, and the Department of Defence is no stranger. So they've got a whole bunch of known PFAS contaminated sites across Australia. I think most, or if not all of their various Defence Force sites with PFAS issues, and they're spending an enormous amount of money just managing it, monitoring. So, I'll give you an example. Yeah, to date, and this is a little bit old, $850 million has been invested by the Department of Defence to manage, remediate, and research the issue. And just in the most recent financial year, they allocated 165 million. So these are, and that's just one potential stakeholder. You throw in airports, various other sites with known PFAS issues. The issue is a very, very expensive one. Lawsuits aside, where's it coming from? So where are the, I guess, hotspots, for want of a better word? It's primarily used, the key sources are the ones you can see here: military bases, airports, flight training facilities. But there's also secondary sources, basically areas that receive PFAS contaminated material or water, such as landfills and sewage treatment plants. And
Right, and
certainly, yeah,
I'll add
you go.
one to that list
Yeah.
as well. Places where we've had historically large bushfires as well, such as
Mm,
down in Victoria.
yeah. But if you want some more depressing news, like if you look at the PFAS Environmental Management Plan, this is a really useful guideline put out by the heads of EPA Australia and New Zealand. They have 4 pages of sources of PFAS contamination, and it's an extensive list. So it's everything from bitumen to beer, basically. So. And obviously, there's various papers that talk about the various sources of PFAS. Um, but long story short, it's pretty much throughout our our land areas and water environments, and certainly stormwater is a massive source. Stormwater is a massive conveyance pathway to other environments. So whether it's the firefighting foams, or consumer, what do you call it, materials like waterproofing, waterproof jackets, cosmetics, etc. Fundamentally, there's a whole bunch of different ways that humans are exposed to PFAS, and like I said before, it is causing various issues. There is guidance and regulation around this. So the document I referred to earlier, the PFAS Environment Management Plan, this is version 3 of it, released this year. They do refer to a bunch of guideline levels. So they have drinking water guidelines, which we often refer to when we're looking at performance of our systems. But probably the most common one I see is that we get tasked with trying to achieve is these ecological water quality guideline levels. And fundamentally, they are super stringent. So, like, if you're a stormwater engineer, you're probably used to dealing with, TN, total nitrogen concentrations of, between, I don't know, zero point 0.4 to 1.5 milligram per liter, so milligram per liter. Phosphorus, a little bit less, but we're looking at microgram per liters and fractions of microgram per liter. So this is often the target that's the most difficult to achieve. PFOS concentration of 0.00023 microgram per liter. I mean, that is 2/5 of bugger all. But that is often the target that various sites, whether you're doing a road construction project, whether you're an airport or a military base, these are often the targets you're actually being tasked to achieve. So very, very difficult targets to achieve. And the advice from the regulators that I've been liaising with is they might actually be getting more and more stringent. So whilst these targets are really hard to achieve, they might be getting lower. And we're seeing this in the US, increasingly reducing, lower and lower targets around PFAS, whether it's be in the nanogram per liter or basically non-detect levels. So what can we do about it? The PFAS Environment Management Plan talks about various treatment systems, but the ones that are pretty much the treatment technologies that are available in Australia, the most widely used or being considered, generally around separation and concentration. So basically taking water and separating the PFAS from the water and letting the water trundle through and essentially concentrating that PFAS contamination into something, generally some sort of absorptive media, particularly granular activated carbon. So again, there's a few different ways of doing that: absorption, reverse osmosis, and foam fractionation. But probably the most common one is the absorption, at least the ones I see, and that's the one we apply at Ocean Protect. But fundamentally, you are basically taking the PFAS from one medium, i.e. water, into another medium and concentrating that. So that concentrated PFAS still needs to be managed appropriately. And generally, there's probably two key pathways to manage or dispose of or destroy the PFAS. So disposal, and you can, if the PFAS concentrations are below certain limits, there is scope to put it in a landfill facility. So again, targets we often deal with in our role here is we're trying to, well, we need to make sure that the PFAS concentration, say in any sort of absorptive media, is below 50 milligram per kilogram. If it is, it can be taken to an appropriate landfill facility. If it's above that, you are probably looking at something like a destruction. So destruction being super high temperatures in a kiln, etc., to essentially destroy or break up the PFAS molecule or chemical. Any comments on that, Blake, at all?
No, bro.
All good. Yeah, it was interesting. I was at a a Water Treatment Australia conference just on Monday, and certainly the preference is destruction as opposed to putting in a landfill. I'm sort of probably, if it's below a certain limit, I think it's best to probably put to landfill. But again, uh, I can see both the pros and cons for both mechanisms. Just to give you an example of, I guess, one type of treatment technology, and it's around this adsorption, which for me is probably the most common one I see. So Ocean Protect have actually developed a PFAS treatment system, and I just thought I'd give you a quick overview of it, just to give you sort of just a reality check of what it could actually look like. So generally, we're basically taking the storm filter, if you're familiar with our storm filter cartridge, which so to date we've put in over 40,000 of these in Australia alone. And we've basically used, traditionally our storm filter cartridge is a different type of filter media, whether P-sorb or NP-sorb or ZPG, is essentially targeting typical urban stormwater pollutants. So nutrients, so nitrogen, phosphorus, and solids and heavy metals, etc. But we've basically taken that cartridge itself, made a few tweaks. In particular, we've swapped out the filter media. So we've essentially put in an activated carbon blend instead of the typical ZPG or PSORB or NPSORB filter media. And because PFAS is very difficult to remove, but it'll compete in terms of absorption sites with organics and solids, etc. We generally recommend some sort of pre-treatment technology. So the more common one that we've been proposing on various applications is the jellyfish. So jellyfish is just a membrane filtration system. It operates like it's an underground system as well, similar to the storm filter. You might recall we've done webinars on it, but fundamentally, it's really, really good at removing solids and organics. And then after those have been removed, we generally discharge it to some sort of what we call the radial flow PFAS treatment system to target specifically PFAS removal. So again, if you're not familiar with the storm filter itself, it's basically generally an underground asset. So water will come into some sort of chamber or pit. The water will pond a little bit, and I might just pause just a little bit here. The water will come into the chamber, and the float will be activated if the water gets above a certain level. And once that happens, the water basically travels from the outside of the cartridge through the filter media and into the center tube. And after that, the water goes through the center tube and is discharged out of under drainage or a manifold underneath a false floor. And then there's a scrubbing mechanism to essentially enhance the longevity of the asset. So there's a lot of R&D that's been put into the storm filter over 23 plus years of operation, and there's 40,000 of these in Australia, 300,000 plus in Australia in overseas. But we essentially made a few tweaks to it to specifically remove PFAS. Now, I've got some example results here on the right-hand side as an example. So this is just one of the results from one of our studies that we've done, and we've done three field scale studies and one lab scale study to date. You can see here the blue line is essentially the percentage reduction. So again, you can see the concentration coming in. This is some of PFAS, and this is the reduction we're seeing, like roughly 80 to 95%. You can see the light blue line is untreated water, and the orange line is basically what's coming out of the jellyfish. So you can see, even though the jellyfish is a membrane filtration system, really good at removing a whole bunch of pollutants, it doesn't really do anything for PFAS removal. But after it goes through the PFAS filter, the concentrations go way down. So again, really effective at removing PFAS. But having said that, it does have its absorptive capacity as well. So after a certain period of time, so after, say, in this case, this
About
concentration,
470, Brad.
yeah, about 470
470
bed
bed
volumes.
volumes.
The cartridge itself is basically hitting its absorptive capacity, so its performance would deteriorate. So that's when we'd be looking to essentially swap out the cartridge. Blake, do you have anything to add in here?
No, Brad, you covered it all.
Oh, stealing your thunder. Sorry, Blake. You've taught me too well. Um, But yeah, that's the quick insight into the PFAS radial flow PFAS filter that we've got. It is different in that to our conventional storm filter in that because for our typical storm filter a cartridge, we basically look to replace the filter media, suck out the filter media, and repurpose all the other components. Because PFAS is more I guess, a health concern, we essentially leave the filter media in the cartridge itself, suitably remove the cartridge and put it in an appropriate container or drum, for example, and then take that to a suitable facility. Now, again, if the concentration of the filter media is less than 50 milligrams per kilogram in the filter media, we could take it to landfill, but if it wasn't, it'd have to be disposed or destroyed by other means. Um, yeah, and so to appropriately manage or maintain these systems, we do take a sample of the filter media to make sure it's all hunky dory, as in less than 50 milligram per kilogram. But obviously, we're very cognizant of the fact that it is PFAS is a far more dangerous chemical than nutrients and solids and hydrocarbons, etc. So we've been very careful in terms of developing safe work method statements, operation and maintenance guidelines, etc. And they've all been authored independently by Optimal Stormwater. But if you're keen to know more, just jump on that link there. There's a whole bunch of information there, including all our studies and published data, etc. But yeah, fundamentally, we've done one lab scale study uh, done by Mr. Blake Allingham himself. And we've done 3 real-world studies to date. 2 of those are published in a AWARD Water e-journal. All of them show high PFAS removal rates, but we do see a reduction in PFAS removal rates at lower influent concentrations. And keep in mind, we are looking to target really, 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 really low concentrations. So, but there's more R&D proposed. Is that right, Blake?
Yeah, that's correct, Brad. So next year's going to be a very interesting year for our research into PFAS. We've set up a new pilot scale study in Australia
Hmm. Cool. Can't give any
to test
insights.
it, and then pardon.
Do you want to share what you're actually looking to test?
So we're just testing a full pilot scale system with a jellyfish treatment and 2 radial flow cartridges. Um,
Cool.
with automated samplers with remote monitoring going on.
Mm,
And then the other field real world study is just building upon the current studies that we've done at our same site there.
yeah, cool. Great. So yeah, where will this is evolved over recent times. So we this, from my mind, is the only the PFAS, the radial flow PFAS filter was the only treatment system that we're aware of that actually treats PFAS contaminated stormwater. So we thought it'd be mainly used for stormwater projects for military sites, airports, etc. But I'd say 95% plus of our inquiries are from groundwater contamination sites. So often, for example, a road project, they're dewatering groundwater, and they need to they've realised PFAS is in the groundwater, and they need to achieve very strict targets. So subsequently, they need some sort of treatment system, even if it's a temporary system. So a lot of our treatment systems are proposed to operate just for 2 to 3 months whilst they're dewatering the groundwater. There's and just again, just to give you insight as to just this treatment system that we've got, there are a bunch of key considerations. We need to know what the concentrations coming in and the flows are like. We need to know what the solids concentration, the other water quality indicators. These all affect the performance of the system. And also, we obviously need to know what target we're looking to achieve. So, if we need to do a multiple pass system, so if we run it through one set of cartridges, it might not be able to achieve the target straight away. So, we might need to pass it through 2 or 3 sets of cartridges to achieve those really, really low concentrations. And obviously, be very mindful of operation and maintenance requirements. Just to give you an idea, so this is sort of the treatment flow rates that we're dealing with for our system. And so every system, like whether it's ours or anyone's, will have an absorptive capacity, after which we generally need to replace in our case, the cartridges. For most applications I've seen to date, we're looking to replace the filter cartridges roughly every 1 to 10 years. Um, so yeah, and again, the different cartridge heights, etc. But again, we're looking to take out the whole cartridge, leave the filter meter in place, and take it to an appropriate facility depending on the concentration. Ours has a bunch of advantages. It's obviously it's passive treatment. It can be integrated underground, so good for airports, etc. Um, but the biggest one is probably the cost. We generally find we're at least 10 times cheaper than other PFAS removal technologies. So it seems like it's a bit of a winner. But yeah, I guess if you're keen to find out more, just reach out. This is an example configuration. Again, just to give you an insight as to what some of these systems might look like. This is a big system treating 44 liters a second, so 44 liters a second constantly. Can't tell you where or for who, but it's a big system treating a lot of water all the time. So to handle that, we basically operate each stream. So there's two banks of cartridges per stream. So for the first 8 hours, it might go through stream one, so get treated by a bunch of cartridges, and then discharge to a second bank of cartridges. And then 8 hours later, it will switch to the second stream. Same thing again. And 8 hours after that, switch to the third stream, and then the next day it'll repeat the process. Basically, just giving the time for the system to sort of, I guess, dry out a little bit before trying to treat more water. Um, any comments on that, Blake, at all?
No, bro.
Cool. And this gives you an idea of what these things look like underground, storm filter cartridges. Cool. I often get asked when I talk about PFAS, what about nature-based treatment solutions? So bioretention systems or wetlands, for example. Um, there is some research around the application of floating wetlands in particular, and you can see some of the references on the screen there. And this is done including some sites in Australia. I think there's some stuff happening at Mawson Lakes, for example, in Adelaide. But I think the key thing from my mind in terms of nature-based treatment systems is certainly further research is needed, particularly around their effectiveness and in particular their long-term performance. But there's also probably some key risks associated with nature-based treatment systems for PFAS removal. Like I've touched on before, it's a pretty dangerous chemical, and like when we're replacing our cartridges, for example, we're very, very careful about how they are handled and managed. But I think it'd be a much more difficult process for nature-based solutions. How do you remove, immobilize, the filter media, for example, in a vegetated system, and what do you do with the plants? Could you just, and I've seen this, people proposing just take the plants and put them into feedstock, like for animals, or just put them on the ground for, I guess, for biosolids for agricultural purposes. I think I wouldn't recommend that, I don't think. But also, again, getting back to the fact that these are a nasty chemical and can cause a whole bunch of dramas to wildlife in particular, there's a risk that a nature-based solution will actually act as an ecological trap. So and what I mean by that is that the system could attract wildlife, but the wildlife inadvertently get sick or unwell or die because of elevated PFAS concentrations. So the ecological trap is that they attract wildlife, but the wildlife can't differentiate between, say, toxic environments and non-toxic environments. So for me, that's a key risk that I'd be concerned around for nature-based systems. Having said that, there might be an opportunity to use them for various applications, but I think certainly further research is required in that space. So in summary, PFAS, it's a drama. It's a massive problem, and I think it needs far more focus in our stormwater industry. It's certainly a high and growing priority for environmental regulators, and it's not an easy thing to remove from contaminated waters. We can, but it is certainly not easy, and it's not cheap. Clearly, it's far better to stop production and use of PFAS products. Um, and that should obviously be the priority. But in the meantime, for where there's a legacy of PFAS contamination, it can be removed. But like I said, it's very difficult and expensive. Cool. Happy to dive into questions. So if you've got any questions from today, just a reminder, folks, please put questions in the Q&A panel. And again, the slides and recording from today will be made available on our website in a couple of days. But please, if you do have questions, please put them in the Q&A in the chat, and I can see a few have come in already. So Dan Niven, geez, I just emailed you before, Dan, about something completely different. Um, this is a great question, and for me, this is probably the ultimate question. So Dan Niven is a senior water engineer from Premise. So greetings, Dan, in Brisbane, and he asks, I think the $4 trillion question. Dan asks, as a forever chemical that bioaccumulates, is there a safe, in inverted commas, is there a safe level? Blake, do you want to have a crack at this? Give you the hard questions.
Oh no, no, I was sorry. I was reading Dan's second question there about the cost. Um,
Let's do the first question first. So is Dan sorry Blake, as a forever chemical that bioaccumulates, is there a safe level for PFAS?
Going off the top of my head, Brad, I believe that the half-life of PFAS in the body is about 9 years.
Hmm.
So safe levels are continual exposure building up year on year on year on year with a half-life of 9 years. It's going to accumulate it over a long period of time. So the safe levels, I'm going to go with the NEM 3.0 there, Brad, as the safe answer. But they're
The,
probably too high.
yeah, and I agree with you. So I think we've put these, sorry, the regulators have set these levels based on the best available science. And they're super low. Let's face it, 0.00023 microgram per liter is an example. That is nothing. But is that even safe? I'd argue that it probably isn't. So it's
Yeah,
probably the best we can do in the technology we have available. But from my perspective, the targets, the guideline levels aren't getting any higher, as in easier to achieve. They're probably going to
yeah.
lower.
You only have to look at the introduced ecological levels that are lower than the drinking water
Yeah,
levels.
yeah, yeah. And that's the feedback we've had from the regulators. And there's been a bunch of research, I think, in recent times around what is a potentially inappropriate level. I think the jury's still out. So, yeah, I hope that answers your question, Dan. I'm not sure if there is a safe level. Um, so happy to go into a further discussion around that. Jeff Rabich. Uh, he asks, hi, a complexity with the PFAS group, in brackets 14,000 chemicals, is that the breadth of chemicals, e.g. carbon numbers, linear and branch chains have different physico-chemical properties. Yeah. For example, water solubility, LOG, KOW, BCF, bioaccumulation potential, environmental persistence, etc. This makes water treatment difficult. Their toxicity and ecotoxicity and endpoints vary also, and there are relatively few that can be analysed for in a laboratory setting, to Blake's point before. Waste classification criteria and legislation is also very stringent as well. Paper mills are also a source. Look, I totally agree with everything you just said, Jeff. There's not a question there, but I love the comment. Yeah, it's a really complex area, and for my mind, as an environmental hippie, I think it's madness how the environmental industry and stakeholders in this space, the community, the public, etc., wildlife are basically scrambling to try and address this issue. We need to do our best to just completely ban and stop the production of these chemicals and also limit the evolution of new chemicals in the PFAS group. So it's 14,000 now. What's going to be in 5 to 10 years' time? It's going to be even more difficult and extensive. So, yeah, we put in a treatment system to try and remove it in water streams. But again, the focus should definitely be on avoiding production in the first place. But it is a very, very difficult issue, as you've touched on. Yeah, Sean Quilty, great. Sean, one of our presenters of the Stormwater Fundamentals series. I think he punched out three very popular sessions this year. Greetings, Sean. Sean asks, and you always ask a question. Let's face it. And thanks for the question, Sean. Sean asks, any estimate on when PFAS removal targets may become legislated? What do you reckon, Blake? I'll chime in.
I think that's gonna be a longer process than we'd like, but hopefully in the next 2 to 3 years, I'll think it become legislated.
I don't know. For my mind, I guess I just deal with the targets that we get asked to achieve, and it seems like they're. I'm not sure if I'm not sure what the terminology is. I'm not a lawyer, but they're certainly targets that we have to achieve.
Yeah.
So, does that make it legislative? I think it might under various legislation, maybe if you knowingly or potentially causing environmental harm. that would be come under the remit of if it's above a guideline level. I mean, that's certainly the case, I would have thought. So I'd suggest they might already be legislated, at
I
least
was
for some
referring to
applications.
stormwater,
Yeah,
stormwater.
stormwater. No,
Yeah,
I'm saying. Well,
yeah.
sorry. Yeah, I am talking about stormwater and contaminated groundwater as well, at least for the
Mm,
ones that we see.
yeah.
Yes, but in terms of what do you call it? A typical urban development. You know, we're obviously focused under the state planning policy on nutrients and solids and gross pollutants. Yeah, I don't know if and when they'll ever start talking about PFAS. Obviously, there's a lot of chemicals of concern from even typical urban stormwater sites. Um, but I think I'm not sure if they'll be prescriptive around the targets, but I think there might be something prescriptive around um, ensuring some treatment system is present to remove some PFAS. I think that's my, but I don't know. Who knows where the regulation might end in time. Another question from Dan Niven. What is it that makes you cost so effective to your competitors? He's talking about the Ocean Protect PFAS treatment system. Does the way it is disposed of make a difference to the costs? Blake, do you want to have a crack at this first?
Yeah. So, um, most of the competitors will have the same rates of disposable that we'll get, and that'll only really vary depending on the quantity of material being dumped and the amount of contamination within that. So that's a level playing field pretty much amongst all competitors. The big difference for us is the vessel that we choose to house the media in, and that being a modified storm filter. It provides a significantly reduced cost compared to the larger heavy duty vessels that our competitors are using. That um, that and the ability for us using the storm filter to operate at about 24 bed volumes per hour in comparison to the typical 5 to 7 bed volumes per hour for our competitors. So we're operating on a much smaller footprint as well.
Mm. Question from, yeah, look, it's interesting. Like from the projects we've priced on, it seems like we're cheaper for CapEx, but also OpEx. But you say we're more or less the same in terms of the disposal requirements. Is that, yeah? Okay. Kerry Baker from Moreton Bay. Sorry, no, Kerry's not from Moreton Bay. That's Jeff. Kerry's from Tompkins in I think Mount Gambier. So Kerry asks, are there any examples of these filters being used in leachate slash wastewater applications where the concentration of PFAS is higher? Do you want to have a go first, Blake?
There definitely are, Kerry. We've had interest in applying our rad flow filter to that exact application at landfills.
Yeah, and it's probably been maybe catalyzed by, I think there was a comment recently, sorry, a requirement recently, and I might be wrong on this. Blake, you might know this better than me. New South Wales, landfills in New South Wales there's a requirement, I think now, that they have to monitor for PFAS in their leachate. And so and obviously some councils are going, well, if we're monitoring it, do we need to manage it, for example? So I think there's going to be growing requirement for PFAS treatment or removal from leachate systems, and certainly wastewater. I'm not sure about that. Obviously, wastewater have a whole bunch of what do you call it, discharge requirements. I'm not sure if do you know of any, Blake, that are actually specifying PFAS limits just yet?
Not off the top of my head, Brad.
That's okay. Cool. Another question from Jeff Arabbage from Moreton Bay Council. Jeff, I think it's a comment as well. Toxicity slash ecotoxicity safe levels under NOEC vary with the type of PFAS compounds. Fate and persistent, e.g. half-life, also vary. So yeah, that's just sort of um, talking about the safe limits of the PFAS compounds. Basically, it does vary from PFAS chemical type to the other. I think that's all the questions we've charged through it. If no one has any further questions, I'll just get up. Um, one of the comments in the chat is development conditions could require certain targets to be met. The breach of the condition could see a penalty under relevant planning act, possibly. Yeah, I haven't seen development conditions specified requiring PFAS removal just yet on at least typical urban stormwater sites, but I
I
could
think
be
we've
wrong.
seen one, Brad.
All right, there you go.
Yep.
Hey, look, and for people who are still with us, if you have any further questions from today, feel free to reach out to Blake and myself. Our contact details are on the screen. I think that's all of them. I think just let me double check. Cool. Hey, that's all the questions, folks. Thanks so much for your time today. And thanks also for your attendance during the webinar series for 2025. It's been a hoot. Hope you've enjoyed it. And we'll look to return back in 2026 bigger and better than ever. So thanks, guys, and enjoy the rest of your day.